Hello students, in this session we are going to discuss the calculation or computation of relative measures of dispersion, their scope and use. So there are two different relative measures of dispersion. One we call coefficient of variation, that is based upon mean and standard deviation, and the other one is the coefficient of quartile deviation that depends upon the quartiles. We use or can use standard deviation and mean based criterion coefficient of variation when the data sets are symmetric. In case of data set are symmetric, we give preference to the use of mean being the most representative measure of the data. So in that case, we have discussed already that there is a tie between the mean and median values. Therefore, we give preference to the use of the most representative measure, that is mean. But in case of skewness, when data are skewed, then it is preferable to use median as a measure of center tendency. Consequently, we cannot use standard deviation as a measure of dispersion. So we have an alternative of coefficient of quartile deviation when the data sets are skewed. So I am giving you two different data sets here in both the examples. So the formula for coefficient of variation, that can be simply denoted as CV, is the standard deviation divided by mean multiplied by 100. And since we are multiplying this ratio by 100, we can interpret our answer in percentage terms. The formula for coefficient of quartile deviation is the interquartile range, that is simply the difference between Q1, Q3 and Q1, and divided by Q3 plus Q1 and multiply this by 100%. So again, since this is the ratio, we can interpret our answer in percentage terms. Okay. Now I'm giving you the example of two workers who are working under same conditions. What we may expect difference in their output in terms of mean and standard deviation if the two data sets A and B are considered symmetric. Therefore, we are going to use coefficient of variation as a measure of relative dispersion to compare the productivity of these two workers. So data set A that I am labeling as x1 bar and s1. So x1 bar is the mean of the first worker, and let's assume that this is 23.5 units and with a standard deviation of 4.2 units. X2 bar is, let's assume it is 25.3, whereas the standard deviation is 5.1. So in that case, let's assume a scenario in which both the workers have the same mean value but different standard deviation values. In that case, we have no need to go for the computation of CV. We can directly look at the standard deviation values, and the person who is having a low value of standard deviation, that will be considered a more efficient worker or a consistent performer. When we have different mean values for the two data sets and different standard deviations, then they will need to go for the computation of coefficient of variation. So coefficient of variation of worker A is a standard deviation for worker A, which is 4.2, should be divided by 23.5 and multiply this by 100. Similarly, coefficient of variation value for B, it is standard deviation 5.1 divided by 25.3 and then multiplied by 100%. Now, if we are going to compute the coefficient of variation values accordingly for both the workers one by one. So 4.2 divided by 23.5 gives us 17.87% as the coefficient of variation value for worker A. Similarly, for worker B, that's 5.1 divided by 25.3. So CV for worker B is coming up as 20.16%, rounded off to two decimal places. So worker A, since worker A is having low coefficient of variation value, so worker A is relatively more efficient because it has a lower degree of variability, relative variability comparatively. Similarly, here for two workers A and B, I'm giving you two data sets. Q1 for worker A is 37.5. Q2 for worker Q3 for worker A, let's assume that it is 52.5, and Q1 for worker B is, let's suppose it is 40.7, and Q3 is equal to, let's suppose, 58.3. Now, coefficient of quartile deviation for worker A equals to the difference of 52.5 and 37.5, which is 15, and this difference should be divided by the sum of the two values, 37.5 plus 52.5, and the answer is 16.67%. Similarly, for coefficient of quartile deviation for worker B, the working is 58.3 minus 40.7 divided by 58.3 plus 40.7 and multiply this ratio by 100%. So 58.3 minus 40.7 is 17.6 divided by 58.3 plus 40.7 is 99. So that's 17.6 divided by 99 gives us 17.78%. So according to this data as well, worker A is working more efficiently. So worker A is more efficient if we compare the coefficient of quartile deviation values for the two workers. With this, that's all for this session.